Hey guys, my name's Nick. I'm here to talk to you about our My Data 613 mini project. This project has to do with NHL stats leaders for the past 10 years. We were tasked with essentially applying all of our knowledge in this course to some degree in this project. Now, there isn't too much complexity to this exercise. It was more of just a display of the techniques that we learned, and I would likely continue this analysis further in the future. So without further ado, here we go. So at the beginning of the code, you can see I just brought in all the packages we're going to need for this. Now there are some that are optional, but most of these help with the scraping as well as the data manipulation and plotting. So I'm just going to give those a run. We'll just make sure these all run properly. Now, the website I used to do this was hockeyreference.com because I was just trying to use your regular RVest scraping package and not have to use Arcelium or PhantomJS or anything like that, or even really CSS selectors. So this is what hockeyreference.com looks like. It's pretty typical. All of these tables are HTML objects, so it makes it really easy to scrape. And then if you look up here, this URL, the only thing that changes in this URL for every year is the year, and that's pretty much the only issue to deal with, other than a few things that I'll talk about later. So the first thing you do is we set our URL to be the hockeyreference.com leak stats leaders website. So that's that URL. Now this is not the only URL we're going to use, but this is what we're going to use as our template for our loop that gets us all of our proper URLs to scrape. So we have a get object here that it gets the URL as an actual HTML object, and then this parses the HTML object into the different HTML objects that are within it, and then this pulls all the table objects out of that HTML parsed. So we're just going to run this whole thing here, and so you'll see now if I go down to my global environment, if I go to tables, this should pop up here. I could also just do it with a view, but oh no, you know what? It'll come out in the next little bit. View tables. Sometimes this works, sometimes it doesn't. Yeah, so all of these tables are each statistic, uh, and all the leaders in each statistic. So it's a list of tables, essentially, what this is, just for 2019. So obviously in this analysis, I've eliminated 2019 because the season isn't complete yet. And again, I'll talk about that moving forward. So now we have to grab the URLs for every leader this should be from 2008, or sorry, from 2000 to 2018. Well, 2019, but we're going to ignore 2018 2019 when we bring it in. So essentially, this is your main page URL. This is this is what happens before the iterable part up here. So essentially, it grabs the links as characters and then also grabs this year as today, so it's much easier than, or as this year, so using the LibreDate package, so it's much easier to just drop that in as opposed to having to put 2019 every time. These are a few things I was trying out, but I didn't end up needing. You're essentially you're creating a list that pastes the year in for each year into this URL. So I'll run it, and you'll see what I'm talking about. So as you can see, I have a list of years that we're going to look at. So actually this is from 1990. So back from 1990, I'm just going to leave that there so that when you guys look at my code after, you can reference it. So this is a list of every link that shows. Right? So now we have to get all the tables for each year. So for that, I've written a for loop that brings in the first URL, or like each URL, and parses it, same as above, and then brings a table for each year, a list of all the tables for each year. Then what I do is I've used the assign paste function to essentially do leaders underscore that year as the list of table, or the list of stat leader tables for each year. So if I run this guy, this might take a few seconds to run. Whoops. If I run this, if you look on the left, you'll see, you might not see it, but I can show you guys. Essentially, it'll create a list of tables for each stat for each year. So this might take a few minutes. Just check to make sure it's running here. Yeah, so as you can see, it's actually generating. If you look at my global environment up on the right, it's actually generating leaders for each year, a list of 38 stats. So this is leaders 1997. So it's again the same stats as the other ones, except there is one issue where there was one stat that came in around 2009 that was shifting everything over. I will explain that coming up here. So now we need to wrangle all the stat names and get them proper, because if you look at the stat names as they are a little bit bizarre. You have slashes and spaces and brackets, and parentheses, and a variety of different things, characters that aren't going to be great for when we're recalling the columns in analysis. So this is just a bit of pre-processing, I guess. So essentially what I've done here is I took all of the names of the columns from the year 2000 and the columns from the year 2009, and I made them a vector of the intersect of those. So only the stats that are common between the older years and the newer years are what's used in this. That will solve the issues of like expected plus minus, as you see at the bottom there, only being present in the later years. So again, I will run you through how I did that. So these are dropped into a stat names vector, and then what I've done is I've g-subbed out all spaces as no space, and then I've g-subbed all slashes as underscores and all dashes as underscores as well. And then for games played goalie, that had parentheses in it, and I just manually adjusted that. And then down here, this is for the year 2009 to, this should be this year in LubraDate. I just did not edit that, so you could do it for up to now, up to say next year, 2020, 2021, so on and so forth. It just takes the leaders for expected plus minus and just makes that null. So it just makes it 0. So then when we go to combine everything and I go na.omit to get rid of all the NAs, all of the year columns line up. So I'll run this guy and you'll see what I mean. It'll output all the stat names and it'll show the changes. So this is what stat names is. This is what stat names is before I make those edits. And now if I look to do stat names down here, as you can see, they've been changed to be a bit more advantageous for calling them out in analysis. So the next thing to do now is to combine, because right now each stat is in each individual year. So the idea is to combine them all into one data frame. Now I decided to use the average of the top 25 players of each year in each stat and put them into a data frame that contained each year the average, for instance, points of that year. and then the next year the average points of that year of the top 25 players for each of these stats. So to do that, this was probably the most challenging part of this whole project, was a lot of this um, sort of data manipulation and wrangling. So what we have to do, so I create a vector here called stat_av frame. So this creates the stat averages, and I'm just going to run this whole thing actually just so we can have a look at what it does. All right, I will pause this video and come back when that is finished running. So yeah, thanks.